What's up? Hello everybody. Long time no see, long time no see. In the video today, we're going to take a look about the integration of the ComfyUI into the interior design workflow. This method wasn't about creating the final product or production ready result, but what is there is that it's going to offer a fast way, the quickly way, and flexible way to prototype the different direction and without losing the proportion, the structure, or the key element of the space. Unlike the completely AI generated image, this workflow is aimed to keep everything is under control. The furniture will go and stay in the display and it doesn't look distorted or it's going to look weirdo with the chair had 7 legs, for example. The ceiling height remain consistent, the camera angle remain unchanged, and so forth and so forth. The generative AI is going to work on top of the existing structure to ensuring the key element of the space remain the same, and while the generative AI going to adding the new visual possibility. So without further ado, let's dive right in. Okay, so now let's break down the workflow I have built in the ComfyUI to generate the design variation. This setup is structured into the 4 key groups and each playing a crucial role in controlling the output while it's keeping the predefined design intact. The first one is the checkpoint model loading and the prompt guider, and the second is the ControlNet to maintaining the predefined as the consistent, and the third one I have in here is the IPAdapter to transfer the style into the spatial, and the final we hook up all of its elements into the sampler to get the final result output. As the foundation of this workflow, I am using the SDXL model as the base model because it provides the high quality output with the better detail and coherence. And this is where we define the overall theme of the design using the text prompt guiding the AI in the generating the relevant result. The checkpoint that I am using in here is the realism engine with the SDXL base model. You can find it on the Civic AI or you can use whatever the checkpoint that you want. In here I really satisfied with the result from the realism engine, so I keep it for my workflow. And also in the additionally I had the custom node SDXL prompt styler, which is going to help me to guiding to writing the style for the my positive and also for the negative prompt. And you can find it on the GitHub page with the SDXL prompt styler custom node. And then I'm hooked up the SDXL prompt styler into the clip text encode, and this is just a basic clip text encode, but I convert the widgets into the input pin, so I will then have the input pin so I can connect the positive and the negative into the clip text encode, and it's basically driving the prompt by the SDXL prompt styler. Okay, so to ensure the generated variations stay aligned with the predefined design, I start with a clay render of the scene, and this is what I'm preparing ahead of time to get each key element of the scene. The purpose of this is to create a solid base for AI to work on, while it's maintaining control over the composition of the scene. And once the clay render is ready, I load it into the ComfyUI as the input image, and to using it with the ControlNet depth and the canny. These two ControlNet models extract the actual structure data of the space, such as the ControlNet depth will then go into capture the depth information to ensuring that the AI will go into respect the spatial relationship in the scene, and this is going to prevent the distortion in the perspective and help retain the sense of the scale of the spatial. Also for the ControlNet canny is we're going to detect the edge to help keep the essential line and the shape of the element like the wall, the furniture, and the architectural detail. This is going to keep everything in play while it's allowing the AI to add a creative variation without losing those key elements. By combining these two, we get a really good structure guide that ensures the AI generated result remain consistent with the original spatial setup, and this is really crucial for maintaining entirety of the space while still allowing for the creativity manipulation by the AI. But to further refine the detail, I pass this process through the ControlNet Tile, and this ControlNet Tile will then help me to enhance the image by adding the additional refinement and the texture information. It's making the final output more detailed and visual rich. For the information of the custom node, the list of the custom nodes that I use to build this workflow, I will then list it down in the description, so feel free to check it out, and you can install it all by the manager, so no worry about that for now. Stick with me, I will walk you through this workflow for you to understand what I am doing in here first, and then after that you can do it by yourself. In here, I connect the input image with the layer utility image scale by aspect ratio come from the layerstyle custom node. This node will then help me to get the original information, the scale, the sizing of the original image, and then after that scale it to the size that I want it to process in the ComfyUI, and then I pass it through the ControlNet depth, ControlNet canny, and also for ControlNet Tile. Also this one I hook up the width and the height of it into the empty lengthen to using with the sampler, and this will then maintaining for me the output. It will then have the same sizing, the same scale, at the same aspect ratio with the original image. It is worth to mentioning one of the really important parameter of the ControlNet canny is about the low threshold and the high threshold. And this one is not have the right or wrong number in here. It's just about the experimentation with the number to finding the right balance spots, and just try it and changing the number to get the answer as the balance for your need. Okay, so now that we will structure the spatial layout using the ControlNet, the next group is about the IPAdapter, which is using to handling the style transfer. And the IPAdapter works by taking a reference image and applying its style, the color and the mood to the AI generated output. And this means instead of manually tweaking the material, the lighting, or the texture, we can use the existing visual reference to instantly create the different design aesthetic. For example, here I'm using two different reference images, one with an off-white wall, the green painting, and a clean and modern aesthetic, and another with the wabi-sabi mood, where nearly everything is in warm brown tone with a natural feeling. And by simply wrapping the reference image, we can quickly explore the different design direction while keeping the structure intact. Okay, let's run this to see the different results from those two different reference images. As you can see in here, the first result take on a slightly green tone, adapting the mood from the reference image. Some details are subtly wrapped into the new direction, like the color of the wall and the wood material, creating the balanced fusion of the original design and the reference style. On the other hand, the second result is quite opposite. The brown tone wabi-sabi aesthetic is applied consistently throughout the image, creating a warm, earthly feeling, and the overall color palette shifts toward deeper natural hues, making the space feel more organic. And this demonstrates how the IPAdapter can quickly influence the mood, the color, and the material perception to the spatial while still keeping the core spatial structure intact. The IPAdapter I'm using in here is not the default one. It's come from the Kolors-MZ custom node, and the specific model that I'm using is the IPAdapter Plus. And in this setup, I'm using the IPAdapter advanced node, which has an interesting parameter called by the weight type. And this option is allow me to choose how the style transfer is applied. In my case, I found that the style transfer weight type is give me the best result. And just try with it and experimentation with the different weight type. And by adjusting this setting, you can fine-tune how much the reference image will influence the final output. Finding the right balance is the key. Too much influence might override important detail, while too little might not transfer enough of the intended style. Now that we will set up the both structure consistency with ControlNet and the style transfer with the IPAdapter, the last step is to process everything through the sampler, which is generate the final image. And for this, I'm using the sampler custom advanced node, which allow me for precise control over how the image is refined and the output. And the setup includes the several important elements, such as the random noise nodes. This introduces the noise to guide the generation process, ensuring the variation in the final output. CFG guider control how closely it may follow the condition prompt, and I will set the CFG value as the 7, and the case sampler I'm using in here is the DPM2 Kolors, and this is the algorithm that determines how the image is generated step by step. And I'm using the step scheduler, and which I'm using the SDXL model with the 18 step, the noiser as the 1, and this control the number of the refinement step taken during the sampling process. And with the 18 step, the result is quite satisfying to me. I'm using the empty layer node, and this takes the width and the height from the original image to maintain the consistency. And as I mentioned earlier in the discussing ControlNet, and once all these components are set up, the output pass into the VAE decode node, which is convert the latent data into a final image. And this is where everything comes together: the structure from the ControlNet, the style from the IPAdapter, and refinement from the sampler. Here we are, my friend. The workflow shows how the Generative AI can assist in rapid prototyping, making it easy to explore different design directions, while with keeping key spatial elements under the control. It's not about creating the production-ready result, but about pushing the creativity without the limitation. And that's it for the video today. Thanks for watching. Let me know your thoughts in the comment, and I will see you soon in the next one.